Go ahead and are you talking to me, Damaris? You want me to go to Starbucks? Starbucks, they don't have dine-in anymore. You go there, you pay $5 for coffee, and you leave. All right. Yeah, but the Starbucks my place is they have a little couple seats outside, but all right, let's go. They have a drive-through now. I see long lines of cars for a drive-through coffee. Okay, moving on. Now we're gonna do logarithmic differentiation. Hey, you guys, let's go ahead and start. Sorry, I know I said 4:35, but that was just to be safe if I was still struggling to get back on. Let's start so that we can finish early too. So sometimes when you're doing logarithmic differentiation is no, I think this time it was my laptop because my iPhone and my iPad were still working. It was just the laptop needed to restart. Although my Wi-Fi does get bad here. So
3.6, Professor?
No, same section. Yeah, 3.6 still. So logarithmic differentiation is where you take the log of both sides. Hence, it's called logarithmic differentiation. Now, on this first example that I'm going to do, you technically don't need to use logarithmic differentiation, but I'm going to do it anyway just to show you the process. So let's say you're trying to figure out what dy over dx is, or y prime, basically the derivative, by logarithmic differentiation. Well, first of all, let me, first thing you want to do whenever you see a radical is write it to the 1/2 power, no matter what. Now, just like the name suggests, you take the log of both sides. So what I'm going to do is take the natural log of this side and natural log of this side. So that allows us to take the exponent here and use the property of log to bring it downstairs. That's the third property that I went over way up here. Where did it go? Right here. Notice this one right here, when you have natural log of a to the c power, you can bring the c downstairs, right, like that. So that's what I did here. So now we got natural log of y is equal to 1/2 times the natural log of x minus 2 times x minus 3. Now what I'm going to do is use properties of logs to split that up more. So we got natural log of y equals 1/2 times the natural log of x minus 2 plus 1/2 times the natural log of x minus 3. I went ahead and distributed the 1/2 at the same time. So now we're going to take the derivative of both sides. The left side, how do I take the derivative of natural log of y? Well, what you're taking the log of goes on the bottom, because y is your happy face. Its derivative goes up top. What's the derivative of y? dy over dx. We'll just call it y prime now in this section. Right, remember derivative of natural log of happy face is happy face goes on the bottom, its derivative goes up top. So in this case, it's like that. Now, what's the derivative of the right side? Well, natural log of x minus 2, that means x minus 2 goes on the bottom. Its derivative of x minus 2 is 1, goes up top. And then you got times the 1/2. So I'll just put the times the 1/2 here. So this one, oh, no. This 1/2 is just right here. And I don't need to put another 1 up here because it's just times 1. plus here you got an x minus 3 over 1, and then I'm going to put the 1/2 here. All right, and we're almost done. So now we're going to multiply both sides by y, because your goal is to solve for y prime. Y prime is equal to 1 over 2 times x minus 2 plus 1 over 2 times x minus 3, whole thing times y. What is y? That's actually given to us in the original problem, the very top line. Y is up here. Square root of x minus 2 times x minus 3. And we are done. Now, could you have done this problem without using logarithmic differentiation? Yes, but it's for practice, because the next one you wouldn't be able to do any other way without logarithmic differentiation. So it's a good skill to have. Maris, I actually like Starbucks. I was just bugging you about it, but I haven't been there for a while because I used to go out. Well, when I was working by going to schools and stuff, sometimes I'd have Starbucks, and I have a Starbucks card. I just got an email from them. We haven't seen you in a long time. We wanted to remind you, you still have $25 in your Starbucks account. I'm like, okay, but what do you want me to do? Go to your drive-through?
Today's the day where if you go, you get like a free drink if you buy a drink or something. I don't know. It showed up on my app.
Oh,
Starbucks, in case anyone wanted to go.
all right. I will ask my neighbor if they want a Starbucks. Oh yeah, we could do a after class party if that's one of what I'm not supposed to meet with you guys. You're supposed to be social distancing. Yeah, I met with my class after our Zoom meeting. So, I would be basically never mind. We all met at Starbucks right after. All right, moving on. Let's take the derivative of y equals x to the cosine of x. So here's the thing. This is something where you would have to use logarithmic differentiation, because this is not a power function, nor is it an exponential function. So a power function would be like this. X to the third, x to the fourth, x to the fifth, x to a number, that's a power function. This is not x to a number, it's x to some expression. Well, what's an exponential function? An exponential function would be when the number is on the bottom, like 2 to the x, e to the x, 3 to the x, 4 to the x, and the variable is upstairs. Do you have a number on the bottom here? No. So x to the cosine of x is neither an exponential or a power function. So you cannot use the power rule or the exponential rule. It's its own mutation. So this is where, to do the problem, to take the derivative, We need to use logarithmic differentiation. Now, the book does a solid for you here. There's guesswork is gone for you. You read the directions, which I know about 5 of you do read the directions. It tells you when to use logarithmic differentiation. Like, for example, say, for problems 39 through 49, or for the use logarithmic differentiation. So do not use logarithmic differentiation unless the directions specifically say to use logarithmic differentiation. You're wondering, what is logarithmic? Oh yeah, we're going to do one right now. So here we go. So the question is, y equals x to the cosine of x. We're going to take the natural log of both sides. So natural log of y equals the natural log of x to the cosine of x. This allows us to use the property of logs to bring the exponent downstairs. So we got natural log of y equals cosine of x times the natural log of x. Now we're going to take the derivative of both sides. What's the derivative of the left side? Well, natural log of happy face, or natural log of y, is y goes up, up. Y goes on the bottom, y prime goes up top. And then on the right side here, we got to use the product rule. First, times the derivative of the second. What's the derivative of natural log of x? 1 over x. Plus second, times the derivative of the first. What's the derivative of cosine? Negative sine of x. All right. Now we're going to multiply both sides by y. So y prime is equal to cosine of x over x minus the sine of x ln x times y. Now replace what y with what y is equal to. Which is the original problem, x the cosine of x. Any questions?
Could you have just kept this this equation as cosine x times 1 over x plus ln x parentheses sine of x, or would that be incorrect? If
Negative sine of x.
Negative sine
Negative
of
sine.
x.
Yeah.
You could leave it like that without combining them, is what I'm saying.
I would give it to you still, yeah.
Okay.
You still got to replace the y. So
Right.
what you're saying is, can I be lazy and just write it like this as opposed to writing it like this? And you just want to leave this like this as opposed to like that? Yeah, you can.
Okay.
And but you still got to move the y over and replace the y with x to the cosine of x. So
Okay, yeah.
while you're going to do that anyway, well, why don't you just clean it up inside the bracket too?
That's true. It's an extra step though.
Yeah. I understand. Life is tough. All
Gotta
right,
make
let
it
me have you guys
easy.
do one before my internet cuts out. Because I don't want to have to meet you guys at Starbucks. Y equals square root of, I'm joking, I'm not going to meet you guys at Starbucks. It's a lawsuit waiting to happen. Y equals square root of x raised to the x power. Now, I will give you a tip here that square root of x, if you change it to the x to the 1/2 power, then when you raise the power to another power, it's really, you multiply, so it's x to the 1/2 x. All right, I did a huge favor for you there. So, okay, you do the rest of it. Use logarithmic differentiation. I forgot to write. use to find y prime. All right, go ahead. Okay, let's go over this. So you take the log of both sides. That allows you to use the properties of logs to bring the 1/2 x down. So you got natural log of y equals 1/2 x times the natural log of x. So far, so good? So then, let me at least do a different color. So then you got the left side, that's when you take the derivative, y goes on the bottom, y prime goes up top. And this side, you got to use the product rule. So first, times the derivative of the second, plus second, times the derivative of the first, which is 1/2. Right? So this was first times the derivative of the second, plus second times the derivative of the first. Now, we can still do some work here. The x's cancel out here. So you got 1/2 plus 1/2 ln of x. Multiply both sides by y. So you got 1/2 plus 1/2 ln of x times y. What is y? Square root of x to the x. That's the original problem. Now, can you factor out a 1/2 from the brackets? You can, but it doesn't really make a difference. So we finished up section 3.6. So for homework, do 3.6. And we'll catch up on the previous sections if you haven't done so already. No, that's right, Anahi. Anahi says, can I write it as ln of x over 2 instead of 1/2? Yeah, so 1/2 ln of x is the same thing as ln of x over 2. It's the same thing. So it's the same thing because that's a 1 right here. Anything else? All right, you guys.
What,
Well,
what are-
oh, by the way, so just remember, I never let you out early. You just left. Kind of like at Damaris is at Starbucks, the internet cut out and she had to go.
Professor, when's our next quiz?
Oh, so the next quiz, we'll pick back up next week on Thursday. So usually it's on Thursdays, but we didn't have one this week because I'm still catching up on grading. I still got to grade a couple other classes. So we'll have, I'll tell you on Tuesday what it's going to be, but we'll have a good, don't miss Tuesday though. Tuesday, we're going to do related rates, which is word problems. But right now, just do the homework up to 3.6. So we did 3.5 and 3.6 this week. Then we're going to do 3.9 on Tuesday. And then Thursday will be the quiz, which will probably be 3.5 and 3.6 because 3.9 is word problems, which will be on the exam. And then, let's see here. Yeah, that's pretty much it. Am I forgetting anything, Aaliyah? I'm too dependent on Aaliyah. I might, what am I going to do when she stops being my tutor?
No, I think we're good. Yeah, 3.9 is yeah, you guys don't want to skip that.
All righty. Have a good weekend. Don't drink too much. Madison, you don't drink at all? Okay, bye.